All right, hi again. You've probably seen this shape. So let's take a look at how we did this in as a plugin. And this is the code. It's just simply placed in the main event in a module. Let's see, we defined pi. We created an object. Let's see, we got the width and height, and did a little bit of a loop that did call some sines and cosines. So let's see what we can do to recreate this. I'm going to start with a new project. See if it'll give us an empty project. No. So we'll make an empty project by adding a module and removing this form. We're going to link to or make a reference to Howler, Dog Waffle. And that is the one in the x86. All right. So we should be good to go now. Let's see. All right. So we do have our Dog Waffle object and stuff ready to go. And we can get started. This shouldn't be too difficult. Remember, I defined pi. I'll make this a constant. And it's what, 3.14159. I think it'll be good for now. And we had a submain. All right, so we should be good to go. Let's and that should be let's see. All right, I'm gonna make a half version of this. The half width and half height is long. All right, comma there. All right. All right, that'll be our center point because our image is drawing at in the center. Now we're going to create a drawing object, and we want to set anti-aliasing. And we want to do a begin draw. And also put it down here in end draw. And the only thing other we need outside of that is whoops, refresh. All right, let's start a loop. Let's see. Let's go to pi, 2 times pi rather. It's the basically a complete circle, and I'll make a step value of like 0.1 for now. Maybe we want a little bit more later. I have a hard time hitting keys today for some reason. We also want a begin shape. Let's put D to begin shape. And our loop will be inside of that. So what we want to do is add a vertex with an X and a Y. Now we just want to define what X and Y is going to be. And we'll do that with sine and cosine, I believe. So we want to use angle to want to do this in polar coordinates. So let's see, d dot polar coordinates. We want a radius and an angle and an X and a Y. This is going to store the values in X and Y, so we have to define what radius and angle is going to be. So we want the radius to be like a value of sine and cosine. So radius equals sine of say 100. No. We want to go. Let's see. N is 0 to 0. We want to do something between 0 and 1, I think, or do we? Let's just put N there. And we'll multiply this by a value, say 100, because we want it to be bigger than a single pixel. Let's make it 200. And then we want an angle. Angle equals. I want to map this to 0 to 3. No, let's see angle. Actually, angle can be N for now. Let's see what we just did. Oh yeah, and we also want to clear the screen. So d dot. Let's see, dog dot. Clear buffer. Let's see how that goes. We want to also define dimension those. And looks like it's going to start up another copy of Howler. So let's get rid of this old copy of Howler. Not sure why that is. It seems that from the development environment, it seems to like opening a new copy, its own instance. So let's run for a second, and let's get rid of this old. Let's see. It's getting confused. All right, there goes the old one. All right. Put that there, and let's see what happens. All right. Well, I cleared the screen. That's good. And a few more things we might want to do while we're here. The angle. We have the radius. Sine of n. And we actually want to convert this to polar to cardinal. We have the radius. We have the angle. Angle equals n. All right. So might want to also define angle. All right. Creating the vertex. We also want to translate this to the center. So this will be in the center of our screen. Let's see. D dot translate. Remember we made half width and half height. Argument not optional. Translation actually takes place in all 3 dimensions. All right, there we go. So we've created a seashell shape. Let's see. I'll try some different value here. Okay, that's better. So the value here is actually the number of little arms we have, or it might be 2 times that value. So let's put 2 there. I think we should get 4 arms. Let's see what happens. Yes, okay. So that makes sense. That's all logical. The value is n is 0 to 2 times pi. So naturally we have 2 of these. We'll make 4 of those. All right. If we want 5, or sorry. 5. It's interesting. So anyways, all right, like I was saying, another thing we want to do is give this more steps. That's not enough steps. Okay, that looks a lot smoother. Actually, a fraction value really doesn't work here. So let's just leave that on 5 for now. And I don't know what. We might use a different value. Actually, is the input for sine a value between 0 and 1 or a value between... I'm not sure. We'll figure that out later. The next thing we wanted to do is add a second sine and cosine to kind of modulate this. So let's make that r equals r times sine of in times 15, make this a bigger one, times 100. No, let's make it 50. Oh, that was a bit much. Actually, that's not right because we're multiplying it by that. Let's see. There we go. All right, that should actually be divided by something. Let's see. In fact, we might want to map this to something completely different. There's a neat function, by the way, for doing that. Make this R2. Say I want to map that value to something completely different range. We know the R2 is in a value from -1 to 1, so let's d.map. Yeah. R2, comma, -1, comma 1, and let's map it to a new range, say 0.5 to 1, and let's see what happens with that. R equals R times R2. Okay, there we go. So that is, we're getting closer to the thing we started to do. There's one more attribute we want, is we want to not just modulate these in and out, but also along the angle. So let's try something like A equals N plus R2 and see what happens. Okay, there we go. So that's a good start. There's some more things we could do to that. Filling it, for example. Use stroke equals true d dot use fill equals use fill true. Actually, the syntax has changed that. We don't use the equals anymore. It's just a function call. All right, that's filled in. We could give it color. We could. Here's another thing we can do with this. Let's put it inside of a d dot begin gradient, linear gradient. We have to give it some parameters. Let's say half width minus 100, kind of half height minus 100, comma half width plus 100, comma half height plus 100, comma then we need colors, so C and C1 and C2. Let's go ahead and define what C1 and C2 are, and we're going to end that gradient while we're here. Let's see, d dot end gradient and linear gradient. All right, let's do this and also this. Let's go ahead and make those BB color dim. That was C1, wasn't it? All right, let's do C1 dot set color 255, comma 125, 28, whatever, 129, comma 15. I don't know. C2 dot set color Something comma. Fair enough. Now we want to also set pens while we're here. D dot set stroke color. And we'll just use that C1 and D dot set fill color. We'll use C2. And let's see what happens here. Did I make a mistake somewhere? It ran, so we should have seen something. Oh, I said this before. These need to be inside of the draw, I believe. So let's see what happens. There we go. Well, something happened. We got a new stroke color there, as you see. And let's just double check everything. And linear gradient, end shape. I wonder if these need to be outside of end shape. Quite possibly. Because we're defining in the thing and then we're drawing it after we end it. That makes completely logical sense. It's not just a quirk. All right, so. All right, there we go. We now have our gradient. We have our shape. Don't know what else we'd really need to do to it at that point. Might modulate a few things here before we finish up, but that's about it. That's how we got there. And let's see. Remember this thing I modulated the angle by? Let's change that to something a little different. Let's change it to 44 and see what happens. There we go. Oh, bird wings or something. Neat. Okay. Thanks for watching this one, and we'll do another tutorial later for some fun and get some more experience with this API, and talk to you later. All right, quick addendum to, let's see, 2 videos back where I did the shape. One silly mistake I made is I defined the constant pi as a long instead of as a single or double. So we were getting just the value 3 instead of 3.14159, 3.14195. Okay. There's a song there somewhere. So just something we should have corrected had we caught it. Moving along, let's see. Let's do something a little bit more with that last example of the bounce of the arc, the projectile. Let's do something similar and then maybe put some bouncing or something in it. So let's start from scratch here. Basically, we had a vector, a position, and a force as vector objects. Let's see, we had a position, a force, and a vector. All right, position. The vector dot x, I'll make 0, and so we don't really need to define that. Dot y equals, was it -1 or 1? Let's see. Let's try -1. I'll make it -2. And then we'll make our position. I'll keep position at 0 for now. In fact, I'll just use translate to make that go to the center. Or then in the drawing object, translate, and I'll put it in the center of the screen. I'm just going to guess at it, say it's 400 by 480 by whatever, I don't know. Sorry, let's see. 640, 480 maybe. Maybe 800, that'd be better. 800 because 600, let's see. All right, good enough. That'll be where we start drawing. And I want a, let's see, I got my force. I want a vector. Sorry, that should have been force. We want a vector, which will be, I want to move a little bit in one direction and a little bit, yeah. Actually, I think this should be positive. All right, so let's do our little for loop thing here. That should be, I got to begin draw. This should be end draw. Let's do a for loop inside of there. Let's go to 500. All right, so let's do what we did before. We'll start with position dot add. Let's do this vector dot add force and position dot add vector, I think is what we did, right? Then we'll draw it, d dot ellipse position dot x comma position dot y comma 0 comma radius. I'll just do 10, and we got to refresh at the end of that. We end the draw, we begin the draw. Let's see, this doesn't need to be in the middle of here. Let's take our begin draw and move it here. We'll clear the screen. All right, so let's give that a shot. Even optional, translate. Translate always has 3 parameters. Use 3 equals. Not sure how I made that mistake. All right. There we go. That was being a little overly ambitious. Let's make this 400 and make this 400. All right, there's our projectile. Now let's define a place where we want this to bounce. And basically Newton's law, the angle of incidence equals the is equal. How's that go? Equal and opposite to the angle of reflection, something crazy like that. Basically, once it hits a certain spot, we're going to reverse this projectile by adding, uh, by just basically reversing this. So now I don't rightly off the top of my head remember to do that, but let's just do that. Let's say if P dot y is greater than, we started at here, we started at 0, so let's make this 100, then if, and let's put some logic in here, then position, then vector equals, let's see, vector dot let's multiply this times the negative value times, actually we're supposed to multiply by a scalar. Scalar is a singular value. If we had multiplied it, it would be by another vector. But multiplying by a scalar lets us multiply by a single value. And in this case, actually I don't want a scalar though. I want to do multiply by another vector. In this case, actually in this case, instead of doing that, let's do just the y parameter equals v dot negative v dot y. That should be it. Let's see. There we go. We got a bouncing ball. Let's make one other change though. You see what we did there? We hit pixel value of 100. We started at 0. Remember, we put this translate in there, so it's starting actually at 400, but internally it thinks it's at 0. We got down to pixel value, y value of 100. It says, wow, we've gotten past that, so let's reverse this. Let's make this y force, the force of this vector, negative. In other words, it bounces and it goes in the opposite direction. Now we're going to take this and multiply this by like 0.9 because, let's see, times 0.9. Because anytime you bounce off of something, you lose some energy, right? It's not perpetual motion. It's gonna lose some energy each time, and eventually it'll come to a stop, or at least it'll be bouncing in such a small amount that you won't really see it, or it'll look like it's just kind of barely jittering. So let's do this. And whoops, let's see. Not sure what happened there. Huh. It's strange. It worked the first time and then it got down here and oh, you know what's happening here is it's still below 100, so it's continually doing that instead of bouncing up like it should. It still thinks it's below. So we need to add a little cheat in here that moves it back to 100. So let's go to, you know what I mean? Let's go to the position dot y equals 100. So now it won't be confused and thinking it's less than 100. This basically is constraining it from going below this value or below our just like in real life, you can't go below the ground, right? Unless you're like, you got a shovel. All right, there we go. We've got a bouncing ball using very simple physics. Let's see if we can animate that again. Let's take this refresh and put it on the inside of this draw loop, and let's also, I think we need to clear. Yeah, let's try it that way. What else do we need to do? We need to move, actually we need to move both of those within the next loop. So let's see what happens here. All right, let's give that a shot. I messed something up. Okay, so Well, whatever it did. Actually, refresh needs to be after end draw. Okay. Okay, like I said, the refresh has to be before the next end or and after the end draw, and we also have to move the begin draw inside the loop as well, so we can actually see this being drawn. Let's do this, and there you go. All right, we also might want to put a clear screen in there, but it's bouncing and etc. etc. All right, so there you go. So that is basically using the vector library, the vector object in Howler to do some very simple physics. We could, of course, do a lot more with that. We could make particle systems and that kind of stuff. I'm sure there's some other ideas we could come up with. Um, Another thing I thought of doing was maybe adding some turbulence in there. Maybe let's try that. As we recall, we have that noise function dim in that we're using in. And let's make another vector, or maybe not another vector. Let's see. How do we want to do this? We're taking the vector, we're adding the force. Let's take the vector and add the noise. So how will we do this? We won't add it. Let's just do it on one axis. Let's add it on the these x-axis. So let's do vector x equals v dot x plus what was it, NSE dot let's do 1D noise is all we need, and we need a value, x and y value, so or just an x value actually. So what do we want to use as an x value? That's an interesting question. Let's take the y value of v dot y and divide it by 100 and soon about 40 and see what happens. This should give us some kind of a little bit of a windy something or other maybe. Give it one more shot. Let's see. I think I need to add like a do events in here or something so I can stop this. Oh, we also need to multiply this by something probably a little bit larger so we can actually see it. Make that a little bit larger. Let's add that do events. Let's plus this. Say times 10 and see what happens. All right. Whoo! Is that a strong wind? That's got us blowing all over the place. Interesting. That is interesting. Let's see. Should be able to stop this mid. Should be able to stop this mid thing. Let's see what else can we do with this. That was a bit much. It's like a wind. Alright. So yeah, I think Y was the right parameter to use there. So that is the new noise function. Let's see what else can we further do with this. Actually should have been a little bit more yet because this is a big image. And it really needs to be a range between 0 and 1 to get the best out of it. Let's see what that looks like. Oops. Not sure what happened there. Huh. Not exactly sure what I'm doing here. Oh, okay. Whoops. Doesn't want to stop for some reason. Maybe I need to make that do events, put it somewhere else. Interesting playing with the different values of this noise. There we go. That's a little more like what I had in mind, but anyways, you can really see the noise affecting that weird bouncing ball motion. All right, so surely there's a lot more we can do than that, right? Let's see, what else can we do with a vector? Floor and ceiling, dot product. There's certainly some things we can do with dot product. Lerping between linear interpolating between two vectors is certainly useful. Getting the magnitude of a vector is very useful. Normalizing, reflecting. There we go. We could have just used a reflect function probably to reflect this against a different vector, and it would have done that automatically for us. Subtracting. Let's see. Random hemisphere. That's an interesting one. That'll be great for another tutorial. Let's come back to this vector idea sometime later and talk to you then. All right, hi again. Up until now, we've been talking about using the drawing object in Howler in the new API, and that's all good. But sometimes you want to access pixel data, and there's a couple new ways you can do that. So one is to use the new Howler image object. And let's take a look at that. So here we have a little plugin that just basically takes the value of an image and then maps a value to the hue. We did this with, there's a nice little HSV function in the VB color object. But COM, which the Howler interface is based on, COM was not really designed to do millions of things like in a loop. It's just it doesn't have that kind of performance. It's like a messaging system, and it's just it would probably fill up the messaging queue or something to that effect too much to call it millions of times. So what we did here was we just did a lookup table. We built a lookup table with all the possible values, which is only 1 to 255 or 0 to 255. So that's a lot less than say a million. And we just use this color object called HSV, and for every possible value, we mapped the value into a hue. We did that basically by dividing n is 0 to 255 by 255. So it's the value to 0 to 1, and then we multiplied it by 360. So that's 360 degrees of hue. And we put that in a lookup table. And then we loaded the image from Howler. We applied this the lookup table to the value of the object. We didn't just use the average value. We calculated the luminance, which is sort of a weighted value, and then we just put it back in the image and sent it back to Howler. All right, so let's take a brief look at this Howler object, this Howler image object. And I'll just start fresh here. Let's all right. You got the image. You can see some of the the functions that are in there. There's conveniently there's a get image size function. We're going to want that, and we give it the parameters width and heights. This is two variables we want to. It'll actually return the value in these two variables. So we want to dim these as long, I believe it is, before we call that. Yes, and then we should have our image size. And at this point, we want a header image, which we've already created. We want to get a copy of the picture that we have here. Let's do that with, let's see, there's a couple different functions we can do this with, but let's use get pixels. And it takes a pointer to or it takes a buffer, basically, and it fills it out with the pixels in our image. So let's put buff here. There's a couple parameters here we can see what those are. It's use alpha, put false there, it defaults to false. These are optional parameters. And there's a format string. This is an interesting one. It's basically literally a string like RGBA, or it could be BGRA, or it could be ARGB, or something, any combination of those letters. And that is basically the order that we're going to get the pixel values. I'll just stick with the default value, so I won't specify that. We do have to dimension this array that we're using, so we'll go to dim buff as byte, and we'll redimension it. The width -1, height -1. No longer, formerly we had a padding on our images. We no longer have that padding when we use this. When we use these functions here, we don't have to worry about the padding. It's just literally the correct size. So let's see. Not sure. Oh, I forgot to specify that. All right. Redimensions that to the correct size. Let's see what we call. I want get pixels, not set pixels. All right, so we should now have a copy of that image. Let's do a for next loop. Y equals 0 to height -1, or x equals 0 to width -1. And I'll do it next while I'm thinking about it. All right, so what we want to do to read these values is we want to multiply the index by 4, because this is these values are stored. Oh, this is another thing we need to do. These values are stored 4 at a time, so we need to multiply the dimension by 4 and then subtract 1. Because remember, in VB dimensions, when you dimension an array, it's the upper dimension. It's not the actual size. So you have to subtract 1 from it. Okay. So now that we've done that, we can go ahead and read these. So buffer x, let's see, x times 4, comma y, g equals buff 1 plus x times 4, comma y, b equals buff 2 plus x times 4, comma y. And you get the gag here. Is the pixels are packed into this array of bytes. So now that we have the images, let's do something. We'll just make them negative. That's real simple. But you can do really anything you want to at this point. Then we'll just put them back into the and that's about the gist of it. Now we just have to refresh the screen. refresh there. Actually, I believe there's a refresh in this iObject too, so we'll use that one. And let's see, that should be it. I might have made a mistake or two, but that should be it. Let's see, did I mix something up? Oh, there we go again. Like I said before, for some reason, when you're in this development environment, it likes its own personal copy of Howler. It doesn't want to use the one you have open. But once you compile this, it won't act like that again. So we'll just go ahead and use this copy here. A little bit of a hassle. Not much you can do about it, probably. Let's see. And we're back. All right, let's see. Let's load an image in here of some sort, or we'll just render some noise of some sort. Okay. Should invert that. Whoops, overflow. What did we do wrong? Equals R. Let's see. R equals. Well, it's supposed to be negative R, not -1. G. Boy, you can't type and talk at the same time, I guess. It should be 255 minus, by the way, not negative. Anyway. Alright, so what happened? Overflow again, huh? Not entirely sure what's happening here. Okay, that time. Oh, one thing we haven't done is send this back. I.set RGB. Let's see, set RGB, and then we give it that buffer, and actually we want set pixels buffer, and we have those same optional values there, but we don't need them. All right, so let's give that a run. And there we go. We inverted our image. We can change this. We can make one of those 0, and it would make it yellow, that kind of thing. One thing we should do when we're writing a filter like this is save and undo. All right, so save and undo. That way we can restore that later. One optional thing you can do. Oops. One optional thing you can do with save undo is give it an undo string. So on the undo browser, you'll be able to see what actually created that undo point. So let's call this invert and make yellow, whatever. So save it, run it, and while we're thinking about it, let's look at the undo buffer. Yeah, undo and make yellow. It's there. All right, so that is a look at the new way of working with pixels in Howler. There are some other options there, but it fixes some of the basic problems of the original setup, like having an extra padded pixel, and it gives some other options of how pixels are stored. There are also some other things in there. I said get RGB. That way you can still get separate or red, green, and blue buffers if you want to in byte arrays. Let's see what else is in here. You can get the alpha by itself now. Let's see. You can get the selection. That's sort of in there for the future. They probably both do the same thing. And that's about it for that object. It's really alpha blend with undo. That's an interesting one as well. It's really a simple object. It just takes care of that one thing of getting and setting pixels. So let's look at this briefly though. Alpha blend with undo. This is the way we support alpha channel blending. Let me render this back out to here, and say we had a selection on there. See, none of our code here actually is doing anything to support alpha channel, but what we do is we call that right here, after setting the pixels, we call that I dot alpha blend with undo, and there you have it. Now everything only takes place inside of that alpha channel, even though we didn't write any code for that. What that does is it takes this undo we saved and alpha blends it with the selection. That's like an automatic way of supporting alpha channel without having to write any code. So thanks again for watching, and talk to you later.